compound event. It combines two or more events using words and or. Yeah, I know, it's kind of weird, isn't it? So you want to find out the chance of two things happening. So we're just going to jump right down here to these two words. Mutually exclusive. Just means that they're different from each other. There's no overlapping. Okay? There's nothing that meets for both of them. So here's the two events we have. So we're going to roll a dice. We want to know the chance of either rolling a 3 or rolling an even number. Okay, so let's look and see here. There's a Venn diagram. You all know Venn diagrams, correct? The first one, I don't know what these numbers mean, nothing. The first oval here is event A. The only way you can get a 3 is a 3, correct? Then it says, or the chance of rolling an even number where there's 3. This is supposed to be a 2 here. There's 3 even numbers in event B that qualify. So set A has 1 number and set B has 3 numbers that would work. We want to find the chance of this happening. So what you do is you just set up the probability. Oh wait, you should know what this means. What does this mean? We've talked about it. What's the P stand for? Probability of getting a 3 or a what? Okay. 3 or an even number. And this is supposed to be an equal sign. It's not a minus. It's just a messy copy there. That's supposed to be an equal sign. So you might want to correct that. So what you do is you just add the probability of the first event, which is our A, 1 out of 6 chance of getting a 3. You add it to the probability of the second event, which is our B. And to get an even number, you have a 3 out of 6 chance. So you just add the two probabilities together when you have an OR like that. So they already have a 6 in the denominator, so that's easy. So all we do is we leave the 6 in the denominator and we add the numerators, which is 4. And then we can reduce that to what? 2 out of 3. So we have a 2 out of 3 chance of getting rolling a 3 or rolling an even number. Those are the things we're looking for, which kind of makes sense because there's a lot of possible outcomes. There's 4 possible outcomes out of 6 for that. Okay? Down here is just the general formula. It says the probability of A or B occurring, these are your events, is equal to the probability of A plus the probability of B. So you just add the two probabilities together. Okay? They're not affected by each other. All right, overlapping events. Let's see what happens here. So your first event is rolling an odd number. So my first A here has 3 numbers that qualify, 1, 3, and 5. 3 numbers that qualify for an odd number on a die. Then event B says roll a prime number. Well, there's also 3 numbers that qualify for rolling a prime number, and that is 2, 3, or 5. Oh, but wait. How is this picture different than this picture? 3 and 5 qualify for both events, don't they? Yes. That's called overlapping. So there's overlapping here. If I write down what I have here, I have a 1, 3, and 5 for event A, and I have a 3, 5, and 2, because you're not always going to draw a Venn diagram. You can see that the 3 and the 5 are meet both requirements. That's called overlapping. So you have to do something slightly different when that happens. Set A has 3 numbers, set B has 3 numbers, and there are 2 numbers in both sets. So here's what you do. The probability of getting an odd or a prime, this is an equal sign, is still the probability of the first event, which is 3 out of 6, plus the probability of the second event, but you have to subtract the numbers that overlap. Because otherwise you're counting the probability of a 3 occurring twice, and you're counting the probability of a 5 occurring twice. So you just have to subtract those overlap numbers. There was 2 overlap numbers, so I subtract 2 over 6. So that I will get an accurate probability of this happening. So 3 plus 3 is 6. Take away 2 is what? 4 out of 6. And it's completely coincidental that we got the same numbers here. Completely coincidental. So here's the formula for this. Overlapping. The probability of A or B occurring, it starts out the same. You add the probability of the first event, you add the probability of the second event to that, and you take away the probability of the overlap. That's the overlap, the number of times numbers occurred more than once. Yeah? It's not too bad. Let's practice this a little bit. Turn over. All right. You roll a number cube. Find the probability of rolling a 1 or, it kind of tells you that you're going to be adding these two together, or a number greater than 4. All right, so I have a 1. What numbers are greater than 4 on this dice? What numbers are greater than 4? 5 and 6. So these are the two sets of numbers. Do I have any overlap? No. There isn't a 1 here, and there isn't a 5 or a 6 here. So I'm just going to add the probability of each event together. What's the chance of getting a 1 out of 6? 1/6. Add to it the chance of getting a 5 or a 6, which is what? 2 out of 6. 3 out of 6, you have a 1/2 chance, which makes sense because we're talking about 3 numbers on this dice, right? So it makes sense. All right, find the probability of rolling a 2 or, this is kind of your clue that you're going to be adding them together, a 2 or a 5. Oh, there's no overlap, right? A 2 is not a 5 and a 5 is not a 2, is it? So what's the chance of getting a 2? 1 out of 6. You add to it the chance of getting a 5. So your probability of getting a 2 or a 5 is 2 out of 6 or 1/3. Okay? All right, now let's look and see. Okay, the probability of getting an odd number or a number less than 5. What are the odd numbers on here? I'm going to list them, 1, 3, and 5. And what are the numbers less than 5? 1, 2, 3, and 4. Okay, how many overlapping do I have? How many in both?
2.
Yeah, a 1 and a 3 shows up twice, so I'm going to make a start of myself. Overlap. 1 and 3 overlap. Just make sure I don't forget to do that. You can underline them or you can do whatever. So I remember then if there's overlap, I still add the 2, but then I subtract the overlap. So odd numbers, I have a 3 out of 6 chance. Less than 5, I have a 4 out of 6 chance. And what do I subtract? 2 out of 6. So what's the chance of getting those events occurring?
5 out of 6.
Correct. 3 plus 4 is 7. Take away 2 is 5 out of 6. Of getting an odd number or a number less than 5. Yes, Chris?
If it's that obvious, do we actually have to do all that?
Do you have to write all this out? No, you'd have to show me this, though. You'll have to show me work.
Even if it's pretty much saying 5 out of 6.
Yes. You have to show me work. You're going to get that answer all through high school math. I know. Yes.
For the part where they overlap, say that, well, I don't know if it would be able to happen, but, like, say you had, like, how the 3's on one side and then the 3's on the other. What if you had 2 3's on one side? Like, would that happen?
For this instance, I don't think that would happen. I don't think so, no. I've never seen that. All right, you guys do the last one. Yes, no, maybe? 3 out of 6 of a number less than 4, plus 3 out of 6 of an odd number, and then take away the 2 that overlap. 2 out of 6, so you get 2/3. Cool? That's it for today. Here's what you get to do for homework.